there folks, Mr. G here with another educational video. Today we're starting our new unit. Now, some of you might have a test on Friday, some of you are having the test on Monday. This will not be on that test. So this is the start of our new unit, this is new stuff, but if you're working on this on Friday, that's great. It's not going to be on the test, so don't worry about that. Today we're going to be talking about ratios. Now, a ratio is a mathematical tool where we compare the size or the number of two and possibly more things. Now that sounds like a kind of a wordy thing. Let's take a look at an example. One of the most common places you see ratios is when we're talking about screens. And they have something called an aspect ratio, which just compares the height and the width of a screen so that the video fills up the whole screen. Because if your height and your width of the screen and the video that's playing on the screen don't match, then you're going to end up with these little black lines on the side. And I'm sure you've seen that all the time. Now, most widescreen TVs are 16 units wide for every 9 units tall. This is our ratio. We're comparing how wide it is to how tall it is. So if we had a screen that was 16 inches wide, that widescreen would have to be 9 inches tall. We could also double this. We could have a widescreen that is 32 inches wide. It would have to be then double the height, so it would be 18 inches tall. Now the way that we would represent this using a ratio in mathematics is we would say 16, or we would write 16 with these two dots here. This is a colon and then a 9. This ratio we could write as 32 with a colon and then an 18. What you'll notice is that when we go from one ratio to the other in this case, we're multiplying by 2. Now we've seen this before, right? This idea that you can multiply one side by 2 and the other side by 2. This kind of looks like a fraction. And if these were fractions, we would call them equivalent fractions. In this case, these are equivalent ratios. And again, this equivalent, that just means that they're the same. So saying something that is 16 inches wide is 9 inches tall, right? That's the same ratio as a screen that has 32 inches wide and 18 inches tall. So it would have the same aspect ratio. So 16 to 9 is the same as 32 to 18. These are equivalent ratios. Because we multiplied one side by 2, we multiply the other side by 2 as well. And this would be our ratio for width to height in this case. Another place where we see ratios is when we're looking at maps. They have something called the scale ratio that tells you how large the actual space is compared to the map size. So for instance, 3 centimeters on a map might be the same as 15 kilometers in real life. Because a map is a lot smaller than the real space, this is always going to be a small number compared to a really big number. So if we wanted to write this as a ratio of the map scale to the real life scale, we would have 3 centimeters colon 15 kilometers. Now the units are important here because in this case they're not going to be in the same units. This is centimeters, this is kilometers. Kilometers are a lot bigger than centimeters, but we can still write the ratio like this. What that would tell us is if we had 6 centimeters on the map, how far would that be in real life? Well, this was the same as multiplying by 2. So we would have to multiply this side by 2. So 6 centimeters on our map would be equal to 30 kilometers. But this also, just like for fractions, works if we're dividing. So if we want to know how far on the map it would be for 5 kilometers, in this case we're dividing by 6, we can do the same thing on the other side. Dividing by 6, this would be equal to 1 centimeter. So 1 centimeter is equal to 5 kilometers. Remember, these are all equivalent ratios. They all mean the same thing. However, just like with a fraction, if we can get these two numbers to be as small as possible, that means we are in lowest terms for our ratio. So in this case, I was able to make this side a 1 and this side a 5. That would be the lowest terms. I can't divide this by anything else. Another example of this is when you're mixing something. So to make our school hand sanitizer, it's about 7 parts alcohol to 3 parts water. What that means is if we were trying to make a batch where we had 7 liters of alcohol, we would need 3 liters of water to mix with it to give us our final result of 10 liters of hand sanitizer. So if we wanted to look at the ratio of alcohol to water, our ratio would be 7 to 3. Now, is this in lowest terms? It is actually, because we can't divide anything by 7 and 3 that's a whole number. So there's no factor that's shared between, so this would again be in lowest terms. But we can also compare the ratio of how much alcohol there is to the total, which is really just the hand sanitizer. In this case, the alcohol to the total ratio would be 7 to 10. And again, this is in lowest terms. If we're comparing two parts of our mixture, so this is one part of our mixture and another part of our mixture, this is called a part-to-part ratio. If we're comparing one part of our mixture to the total, this is called a part-to-whole ratio, because we're comparing one part of our ratio to the total at the end. Now, when we have a part-to-whole ratio, this is like saying in our mixture that has 10 parts, 7 of those parts are alcohol, so the ratio, or the fraction, that is our alcohol to the total would be 7 over 10. So a part-to-whole ratio is the same as a fraction, because when we write a fraction, we're looking at the part that's shaded to the whole number of pieces. When we do a part-to-whole ratio, it's the same as a fraction. But a part-to-part ratio is not the same as a fraction, because a fraction requires that we're comparing one part, in this case the shaded part, to the whole, not one part to the other part. All right, let's try using this in an example. We got a box of Smarties with 6 blue, 8 red, and 12 green Smarties. The first question is, what's the ratio for blue to green Smarties in lowest terms? Well, we know that we have 6 blue and 12 green Smarties, but now we want to reduce this to lowest terms. That means we need to try and find numbers that we can divide on both sides so that we still get whole numbers afterwards. You'll notice both of them are even, which means we can divide by 2. We'll get 3 and 6. And you'll notice both of these can actually be divided by 3. So here's what our ratio would be for blue to green Smarties in lowest terms. Now remember, this is a part-to-part ratio. This is different from a fraction, so we wouldn't be able to write this as a fraction. This next question wants us to write the 3-part ratio for green to blue to red Smarties in lowest terms. Now a 3-part ratio is exactly what it sounds like. There are 3 parts. We've got 12 green, 6 blue, and 8 red Smarties. And this is how we would write it, with this colon or the 2 dots between each of them. If we want to reduce this, we need to find a number that we can divide all of these by. Notice all of them are even, which means we can divide all of them by 2. Once we're here, it might take you a little while to figure it out, but at this point, there's no number that we can divide all of these by that we can reduce our ratio, so this would be our ratio in lowest terms. This is also a part-to-part ratio, or I guess a part-to-part-to-part ratio, because these are just the individual parts. We're not comparing it to the whole. Our next question is, what comparison of Smarties is equivalent to 2 to 3 in this situation? So now we got to do a little bit of thinking. We got to try and figure out which ratio is equivalent to 2 to 3. We already know the ratio for blue to green Smarties. That's 1 to 2, so that's not going to be right. But we could try some other combinations. What if we try blue to red? We know that we have 6 blue Smarties for every 8 red Smarties. Here we can reduce both of these by dividing by 2. At this point, we can see that we can't reduce our ratio any further, and it's not equal to the one we're looking for, so this is not going to be the right answer. I guess the only other combination we haven't tried is green to red. We know we have 12 green Smarties for every 8 red Smarties. In this case, not only can we divide both of these by 2, but we can actually divide both of them by 4. This divided by 4 would give us 3. This divided by 4 gives us 2. And we see we actually get really close to the answer. We have 3 colon 2 instead of 2 colon 3, but that tells us that the correct answer is the one where these two swap. So the ratio that we're looking for is going to be the other way around. So our ratio for our answer, it would be red to green, which is these two swapped around. That would be 2 colon 3. And there's our answer. Finally, we want to compare the number of red Smarties to the total of number of Smarties in a box. We're going to use a ratio, a fraction, and then find what percentage of the box is red Smarties to the nearest tenth. So that's a lot there. Let's first start with the ratio of red to total. Keep in mind, this is an example of a part-to-whole ratio. And this would be equivalent to a fraction, if you remember what we talked about before, because we're comparing the number of parts to the total number, which is the same as what we do in fractions. Now you might not remember it, but there were 8 Smarties that were red, and our total Well, we had 8 red Smarties, 6 blue, and 12 green. So we got to add all of those together, and we would get 26 to 8. Now we can reduce this. Both of these can be divided by 2, which tells us that we can add a ratio of 4 to 13. We can't reduce this any further, so this would be our ratio in lowest terms, which we can write as a fraction in lowest terms by just putting 4 divided by 13. Because this ratio and this fraction are the same, we're comparing one part to the whole. Then to get a percentage, what we would have to do is do division here. So we want to make this into a decimal. If we plug this into a calculator, we'll get something like 0.3076923 ... If we want to make it into a percentage, if you remember this maybe from last year, we take our decimal place, we move it back 2 times. So our percentage would be 30.76923%, which is the same as 30.8%. So about 30% of our box is red Smarties. We're going to be talking a lot more about percentage later in this unit, but I want to do a quick reminder of how we go between decimals, percentages, fractions, and all of that. So if we start with a percent, say something like 35%, this is the same as if we take our decimal place. So if we're going from decimals to percentage, we move it to the right. If we're going from percentages to decimals, we have to move it in the opposite direction. So we would move it to the left. So our decimal for this would be 0.35. To write this as a fraction, we take our percentage, 35, and we divide it by 100. So this would be our percentage as a fraction. So that's how we go from percentages to decimals to fractions and all the way back and forth. We'll do a lot more examples with this later on in this unit, but for now, that's probably good enough as a refresher. Alrighty folks, let's check your understanding. We got a question on here, so pause the video, grab a piece of paper, and try it out for yourself. And then we'll go over the answers in just a moment. All done? All right, let's go over the answers. The first one, we want a fruit to milk ratio in lowest terms. So our ratio that we're given up here is fruit to yogurt to milk. So if we want fruit to milk, it would be 4 to 10, which we can reduce by 2. So we're going to divide both of these by 2, and we'll get 2 to 5, and that would be our ratio in lowest terms. Now, what ratio of ingredients is the same as 2 to 8 in this situation? Well, let's try a few different examples. We already know that the fruit to milk ratio doesn't match this. It's 2 to 5, not 2 to 8. So what if we tried the milk to yogurt ratio? So our milk is 10, our yogurt is 1. So this is definitely not going to work, right? We could make one of these a 2 by multiplying both sides by 2, but that would be 2 to 20 instead of 2 to 8. So I guess we try the fruit to yogurt. So fruit is 4, yogurt is 1. So if we want to compare it to this, we need one of these to be a 2. So if we multiply both sides by 2 here, we'll get 8 to 2. We got the order wrong, so again, just like our example, we got to swap this around. The ratio that we're looking for is the yogurt to fruit ratio. That ratio in that order, right, we had to swap the order here, gives us 2 to 8. If you said fruit to yogurt, you'd be close, but not quite correct. Yogurt to fruit. The order does matter. The recipe says it's more than 30% fruit. Is this true? Well, we need to figure out what percentage is fruit. And the way we would do that is a part to whole ratio. We need to figure out what part of the smoothie is fruit compared to the whole. We know that the part of our smoothie that's fruit is 4. We got 4 parts of fruit, and the whole would be 4 plus 1 plus 10. So it would be 4 to 15. As a fraction, this would be 4 over 15, which we can divide to get a decimal. We'll get 0.26666. And if we want to get this as a percentage, going from decimal to percent, we move our decimal 2 times to the right, and we'd get 26.66%, which is definitely less than 30%. So is this true? The answer is a resounding no. For our last question, we're making 600-liter batches of smoothies. How much of each ingredient do we use? For this one, we're going to use a new type of ratio that we haven't talked about yet. So if you didn't get it, don't worry about it. We're going to look at a ratio where we look at parts and wholes. So this is going to be a part to part to part to whole. So we're going to take our original 3-part ratio, 4 to 1 to 10, and we're going to add one extra part, that's our whole. So this would be 4 plus 1 plus 10, which is 15. So we're comparing each part to the whole. Now what we would like is that this whole is equal to 600, right? We want 600 liter batches, so we want our whole to be equal to 600. So what do we need to multiply to go from 15 to 600? That's the same as asking 600 divided by 15, which if you plug into your calculator, gives us 40. So we need to multiply by 40 here, which means we need to multiply all of these by 40. So 4 times 40 would give us 160. 1 times 40 gives us 40. 10 times 40 gives us 400. And from here, now we can answer the question. If this is 600 liters, we would need 160 liters of fruit puree, 40 liters of yogurt, and 400 liters of milk. So this would be our fruit, this would be our yogurt, and this would be our milk. And that's how we would answer this question. Thanks for tuning in, folks. Try out some of the homework. If you get stuck, ask for help on the helpline or in the Q&A, and I'll see you all in the next video.